All right. So for us, all right, the truth of the conditional statement, all right, can be, it seems to be interpreted just because you can tell whether it's true or false. All right, but that brings some false sense of security when you get to something like question number 15. All right, so let's look at question number 15. If the measure of a right angle is 95, then bees are lizards. You would obviously say that's what? Right. So listen, I know, I understand what you guys are saying, all right, and I would disagree also, all right, but there are things that in logic they have come up with things to help you understand. All right. And I asked somebody about this and they explained it to me. I was like, okay, I can kind of see that. But someone who is better at math than I am, and I didn't realize it's really a higher level thing. All right. So to me, if I say if the measure of a right angle is 95, is that true or false? So it seems to me as though it should be what? It seems to me as though it should be false. But then just for my own satisfaction, I printed or I copied this out of the book to just show you. All right. And again, if you're not careful, you'll just think based off of your own wisdom that you know what the answer is. All right. That creates a problem. All right. Now, again, it says to show that a conditional is true, you must show that for each case, when the hypothesis is true, the conclusion is also true. All right. To show that the conditional is false, you only need to find one counterexample. Now, here is, which makes sense. But here's what was the confusing part. When the hypothesis of a conditional is not met, the truth of a conditional cannot be determined. Right? That's what is confusing to me. Like I don't understand if the truth of the conditional cannot be determined. All right. When the truth of the conditional statement cannot be determined, it is considered true by default. All right. So if a statement is not false, if the statement is not false, logic dictates it must be true. All right. So again, I have a little problem with that. But that's the rules of logic. If the statement is not false, logic dictates that it must be true. So now watch out. All right. When analyzing a conditional, do not try to determine whether the argument makes sense. Instead, analyze the form of the argument to determine whether the conclusion follows logically from the hypothesis. All right. So with that being said, we can look up here now and say, if the measure of the right angle is 95, we know that's what? We know that's false.
So it's true.
So it's it doesn't matter what is said over here. It doesn't matter what is said over here. It's automatically what? True. Okay. Now, again, if you want to try to do some research on that for me and try to give me a better explanation, I'm willing to put in some extra credit for that. What?
I like to say like two wrongs don't make a right. Two wrongs make a right. Two wrongs remember like that.
Yes, no, I'm totally agreeing with you, but again, I need some logical explanation. All right, I need some logical explanation. Go.
In this like different universe and a right angle is 95 degrees, then you can't, because we don't know what would happen if the right angle was 95 degrees, you can't prove that these aren't losers as well. That makes so much sense.
Okay. So So I'm not, I know, don't make such a big deal of it. Just think about it for a second. All right. I'm telling you, it's hard for my mind to wrap my head around it. All right. So I'm just asking you to think about it. All right. That's it. All right. If you can't accept it, I agree with you. All right. Some people are actually trying to understand and make it known why that's true. All right. I'm telling you right off the bat, it's not an easy concept. All right. You have to think about it a little bit more deeply. All right. If the measure of a right angle is 95 degrees, well, we know that's false. Right. So by the rules of logic, it doesn't matter what comes after it. It's automatically what? It's automatically true. All right. If pigs can fly, well, what's true about pigs flying? They don't, right? If pigs can fly, that's false, right? Does it matter what comes next? No, it's automatically what? It's automatically true. Now, once again, all right, I'm going to do some stuff tomorrow that might help out with this a little bit, but for now, that's the explanation. All right. If Jacqueline turned 14 years old last year, then she will turn 15 this year.
But then they did.
Yeah, it's true. If I'm 14 this year, I turn 15 next year.
Yeah, okay, I'm willing to listen to what people, I thought it was true.
It's not.
No, I'm asking people to let them give their opinion. That's all we're doing. We're not screaming and arguing. All right, we're allowing people to discuss this. Things are different in other people's minds, how they're seeing things. All right, those you guys are just sitting here kind of going through the motions. It's not helpful to you. Think about it. Go.
So in a month, I'll be able to, I like turn 14, so I'll be able to say this. So like, I will have turned 13 last year, and I'm already 14.
So you turn 15, 14.
But you're still turning 14 this year. Like it doesn't change. No, I already turned. Yeah, but it's.
No, I'm going off of this. If Jacqueline turned 14 years old last year, if she turned 14 last year,
She could already be 15 years old.
But she would
But
still.
she's still turning 15 this year.
You can't turn 2 ages in
It's
1 year.
not a
though.
will.
You turn 13.
But it's still true. She's still in.
She's not skipping the age of between 14 and 15. It's still 13 and a half.
Yeah.
But it's like conditional.
yeah, I don't think if Jacqueline turned 14 years old last year, then she will turn 15 this year. I'm trying to see what you're saying.
She could already be 15 years old.
But that
doesn't matter. It does.
But this year.
Still 15.
But
It's
just stop.
saying that she will turn 15, like there's a fact, so if she is already 15, that'd be proven wrong.
Yeah.
Technically.
If
We
don't think we don't, so then it would be by default false. Right?
I'm trying to understand your logic. If Jacqueline turned 14 years old last year, won't she have to turn 15 the next year?
Well, it could all be like 1 year last year, I turned 13. This year, I turned 14, but I still will turn 14 this year, even though I already have.
It doesn't matter.
Okay, okay. All right.
That's-
Well, it's actually, no matter what age she is right now.
No.
You don't.
Okay, all right, let's move on. All right.
I don't-
If a number is between 10 and 12, then it is 11.
No.
Yeah, I definitely see that can be false. Because again, it doesn't have to be 11. It could be any number between 10 and 12. Agreed? All right. Here we go. Let's move down now. Here we go. All right, now things. Yeah, no, I'm teaching you now the converse, the inverse, and the contrapositive of each true conditional statement. Determine whether each related conditional is true or false. If a statement is false, find a counterexample. So if a number is divisible by 4, then it is divisible by 2. So what I would like for you to do is I'd like for you to write P equals a number is divisible by 4. Q is the number is divisible by 2. All right. Now, the conditional statement, if a number is divisible by 4, then it is divisible by 2, is written if P, then Q. This is the logical way. All right. And that P is supposed to be lower case, not capital. So we just say if P, then Q. All right. That's how you would write it. All right. So what I'm trying to do is I'm trying to prevent you from having to write all of it out. Although we're going to write some of it out. I just hate writing things out because I think it's a waste of time. You have to understand what each means. All right. So if I'm asking you about the converse, all right, the converse is where you switch the hypothesis and the conclusion. So the converse is going to be if what? If Q, then P. All right, that would be the converse. So if I made you write the converse, you would simply say what? Right, if a number is divisible by 2, then the number is divisible by what? Divisible by 4. All right, now is the converse necessarily true?
No.
No, because we can pick a number, 6, right? That's divisible by 2, that's not divisible by 4. So we can say that is what?
False.
False, and the counterexample would be, 6. All right, 6 is divisible by 2, but it's not divisible by 4. So we're okay with that. All right. Now we want to talk about the inverse. Uh-oh. The inverse is just the negation. All right. So the inverse is if not P, then not Q. If not P, then not Q.
Those are sleeping ones.
Yeah.
All
All right. So if we want to write out the inverse, we would simply say what?
No, not divisible by 4, that's not divisible by 2.
Exactly. All right. So you write that out. All right. That would be considered the inverse. If a number is not divisible by 4, then it is not divisible by 2.
Well,
All right. And we can say that's clearly false. All right. And the reason we could say that's false is because why?
22.
All right, if somebody wanted to use an example of 22 or 6, either one of those would be. If a number is not divisible by 4, right, is 22 divisible by 4, then it's not divisible by 2, right? That's false. Okay. Now, the contrapositive. All right, the contrapositive. All right, the contrapositive is just the converse and the inverse. All right, that's all it is. So we would say if not Q, then not P. All right. So we would say what? We would say if no, exactly. If a number is not divisible by 2, then it is not divisible by 4. And what are you saying about that? Yeah, I definitely say that's true. All right. Now, the other thing I'd like for everyone to write down here is if the conditional is true, if conditional is true, the contrapositive, good job, just one second. Contrapositive is always true. You with me on this, guys? If the conditional is true, the contrapositive is always true. Does the converse have to be true? Does the inverse have to be true? No, but if the conditional is true, the contrapositive is always true. Yes, sir.
So the only difference between inverse and contrapositive is that the letters are switched.
Yeah, it's called the hypothesis and the conclusion, right? So up here, the first statement, A, is this, or P is considered the hypothesis.
Oh,
All right, and Q is considered the conclusion. All right, so if the hypothesis is true, the conclusion must be true. All right. All right, if, and this is what we're going to talk about some tomorrow. It's if P, well, we'll just wait till tomorrow. I don't want to get lost. All right, what?
For the, we're switching from converse to inverse, we switching them both make them both negative.
That's what you're supposed to be able to tell me. And I mean that just based off of what? Based off of the symbolism. Right? PQ is the conditional. You hear me? This is where we're starting. So the converse, what did I do?
We just switched them.
That's right. The hypothesis became the conclusion became the hypothesis. You good with that? That's it. That's all there is. You with me? Now I'm looking at the inverse. Did I switch them? I just negated them. Right. And again, I tell everybody this is not math. This is just logic, they call it. Right. So you're just looking at following these directions. You're going to follow my rules. All right. And this is what we call deductive reasoning. You're following rules. All right. And you're basing your statements and logic based off the rules that I supply. All right. This over here now, you're supposed to look at it and say, okay, that's the contrapositive. Right. And the contrapositive is switch and negate. Do we agree with that? All right. And then you come up with the truth depending upon your examples or your counter examples. All right. Everybody's good with that? All right. So in the interest of time, let's just go down to the next piece. Now, the next thing we want to talk about is what's considered a biconditional statement. All right, so everybody needs to write down biconditional statement. if if the conditional I'll show you, if the conditional and the converse are true, it can be written as a biconditional statement. All right, it can be written as a biconditional statement. All right. And the biconditional statement is where we're going to abbreviate, but I'm going to give you some examples. It's going to be if and only if. All right. I'll show you. All right. All right. The biconditional statement will have if and only if in it. All right. So what I want to do is go back up here. All right. I wish our converse, did we say our converse was true or false? All right, it's false. So the biconditional is not going to be true, but we're still going to write it as a biconditional. All right, so if you write it as a biconditional, you would say a number is divisible by 4, right under here, biconditional. All right, you would say a number is divisible by 4 if and only if. Notice that's how I write if and only if.
Wait,
Oh, what?
why is it just if?
I said that's an abbreviation for if and only if. All right, notice how I write if and only if, IFF. All right, I don't know why they do that either, but that's the abbreviation for if and only if. Or you can write it out if you want. A number is divisible by 4 if and only if the number is divisible by what?
2.
Divisible by 2. And we already said that's what?
False.
We said it was false because the converse is what?
False.
The converse is false. All right. Now, this is going to be weird, but we'll talk about it tomorrow. If and only if statements, or let me show you how they're going to do this. Biconditionals, this is the symbolism for biconditional. All right. That's the symbols for a biconditional statement. All right. The conditional statement was if P, then Q. All right. Now, what I want to show you is the biconditional. Well, I really should just wait till tomorrow. All right. But that's the symbolism for the if and only if. All right. So now what I want to do with that is I want to come down here now. It says we're going to try to write each statement as a biconditional statement. All right. So the first thing we're going to do is I want to write it as a conditional statement. All right. So the first part is 2 angles whose measures add to 90 are complementary. So the first thing we're trying to do is we're trying to write it as if then statement. All right. We're going to write it as a conditional first. All right. We're going to write it as a conditional statement. So someone who wants to volunteer for the conditional. All right, I'll let you try, go.
If 2 angles measures add up to 90, then they are complementary.
Please write that out. That's exactly correct. Thank you. If 2 angles whose measures add to 90, then the angles are complementary. If 2 angles whose measures add up to 90, then the angles are complementary. I don't think that was that hard, right? All right. So now we say that is the conditional, correct? All right, so now what we need to do is we need to write the converse. So tell me the converse.
If the measure of the two angles or if
Yep.
the two angles are complementary, then like that.
Exactly, come on. That's exactly right. All right. If two angles are complementary, then the measures of the angles add up to 90 degrees. Now, does it have to be that way? No, I just want to make sure that you can write some sentences down that kind of make sense. All right. It's awkward at times. I understand that. All right. I'm not the best at this either, writing out sentences. All right. But you have to write it so that it makes sense. Is everybody okay with that? Now, would you say that that is the converse true in this case? Yeah, the converse is true. So because the converse is true, you can now write it as a biconditional statement. So the biconditional statement would be, nope. You write, listen to me. You write the statement first, the hypothesis first, then you throw in if and only if, then you write the second statement. So go ahead, try it now. Go, I'm happy.
If two angles.
No, not if, just,
Are complementary if then only if they add up to.
but you switched it.
Okay, two angles. Are complementary.
No, read it right off, kiddo. And again, this is perfectly fine and perfectly normal. That's what I want some of you to do. Get over your fear of being, oh my gosh, I might be wrong about something. Right? You're not going to get better at it. You're not going to get good at it unless you try it. So read the first statement. That's all I'm asking you to do. Read that. Two angles whose measures add up to 90. Oh, see, and that's what I'm saying. It's kind of hard to see that, right? So two angles whose measures are 90 degrees. Ooh. Two angles. Oh, yeah. Two angles whose measures add up to 90 degrees. Say that again. Shh. Yeah, there we go. Not whose. Dang it. Thank you. It's not the whose. That's what threw me off. Say it again. Thank you. Yeah, very good. See, I was trying to read that stupid who's in there. All right. So that's what I'm saying. It takes up some practice. Two angles, measures, add to 90 degrees if and only if they are complementary. All right. So let's go ahead and try 23. I want to write the conditional, and then I want to write the converse, and then I want to write the biconditional.
Wait, the biconditional.
If the conditional is true and the converse is true, then the biconditional is automatically true. All right, so I need someone, come on, take a stab at number 23. All right, we'll let you go.
So the conditional would be if an angle has a measure between 0 and 90, then it is an acute angle.
Yay, very good.
Converse would be if an angle is acute, then it is between 0 and 90.
Then the measure, very good. Yes, and the measure is between 0 and 90. All right, so let everybody write that down, and now you can tell me about the biconditional. I'll be happy with you. Go.
And then the biconditional, wait, hold on, let me think about it.
Yeah, I know this is.
An angle that obtains a measure between 0 and 90, if and only if will be an acute angle.
Say it again.
If an angle.
No, not if.
Oh, an angle with a measure between 0 and 90, if and only if will be an acute angle.
And that's not exactly right, but you see, you're close. Tell him. Let,
If and only if.
yeah, see, and again, I'm terrible at that. You hear me? That was good. All right, very good. Say it one more time for us. Go ahead. Say it again. That was very good. Very good. Very good. The hard part is writing it out so it makes sense. All right, very nice. All right, both of you, that was good. A biconditional, oh, we didn't even say, well, is this true? Is the biconditional true? Yeah, because the converse is true. Do we agree?
What was the biconditional?
Uh-oh, say it loud. She's kind of quiet.
An angle has a measure between 0 and 90, if and only if.
You with me on that? Very good. And it just takes practice. It takes practice. All right. So let's try 25. Let's try 25. I'm going to pause the video for a second. I want everybody to write out 25. Almost forgot. All right, so now let's come down to the next page here. Use the following statements and figure to write a compound statement for each conjunction or disjunction, then find its truth value, explain your reasoning. Sounds complicated, it's not. All right, we're now just learning how to write sentences with symbols. So what does 28? What would that say?
B is the angle bisector of ADC, and a line AD is congruent or something.
Congruent, come on. Yeah, but those aren't lines, those are segments, not that it's a big deal. But these are segments above it, all right? The lines would have the arrows. So she is correct, all right? Now, what I like to do is I like to go ahead and determine the truth of each individual statement, all right? DB is the angle bisector of ADC. So that's true based off of the figure. Do we agree with that? Right, because they're saying that this angle is equal to this angle right there, so that makes it the angle bisector. So I know that's true. The mark on the figure, right? That's how you mark a figure, right? That's how you mark a figure congruent. The red marks right here, this. Now I'm saying it looks a little awkward because it could be talking about this angle right here. That's why I don't like the way the textbook does it. If we're talking about angles, I think they should mark this way. That's how you should see that they're congruent. You with me? But that red line on the book is what I'm trying to tell you. That's how the book marks it. I don't like that. All right. This mark here means that what? Those are equal or they're congruent. So we said DB is the angle bisector. We say that's what now? True. Point CDB are collinear. Come on, guys. False. And AD is congruent to DC. True. So is 28 P and R? Is that a true statement? Yes. Agreed? Yeah, you can write true. I'm totally happy with it. Come on, come on, come on. What is P?
Oh, it's the.
Yeah, it's the statement. It's the statement. So if I was being a pain, I could make you write that whole thing out, and I could make you write out Q, and then I could make you write out the truth. Correct?
Yeah.
Right. But I know you guys are smart enough if you're paying attention and you're not daydreaming. All right. I don't care about writing all that out. All right. I care more about, do you understand the meaning of all of this stuff right here? That's what I care about. All right, I don't care about writing out the words. I need you to follow along with me. Go.
So it would just be, D for ray, DB is the angle bisector of ADC, then AD is equal to DC.
No. Now you're trying to make it an if-then statement. That's not what this is. All right, this is just looking at the individual statements, determining if it's true or false. Remember, if an and statement is true if both statements are true, an or statement is true if one of the two statements are true. You with me on that? All right, so let's take a look at 29. Let's do 29. Q or P. Do we all agree? Now, come on now. This is where I'm upset with some of you guys, because you'd rather sit there and not know than raise your hand and say, please just help me out a second. All right. You have to know the answer. Don't write the answer down because you heard everybody else say true. So you write true down. All right. So now we're going to look at number 30, and everyone in here is going to tell me if it's true or false. Well, I don't know. So what is R? Is that true or false? True. Now, because one of them's true, I can automatically write what? True, because it's an or statement. However, not P. Not P would be what? False. Are you happy? So now one of them's true, so the whole thing is what? Is everybody understanding me? All right, I don't think that's that bad. What? Good. No, it's true. Very good question. Because one or the other or both have to be true. Or statement, listen to me, an or statement, only one of the statements has to be true. Okay, listen, I'm so happy with your question, but listen to me. The rule is in a disjunction, which is the or statement, only one of them has to be true, or they both can be true. That's just the rules of the game. All right. And like I said, I know it's tricky, right? So I'm just giving you the rules. All right. But that's for a conditional or for a statement or statements, one of them or both of them. Okay, yes, sir. Good for you.
Did you say A, B is compared to B, C, or
Yes,
B, A, B, B is not?
yes, that's right. That's how you could write it out. All right. What? Quick. 31. R and Q. Is that true or false? False. Right. And if you wanted to, you could write out AD is congruent to DC and points C, D, and B are collinear. Wow, I couldn't have said it better myself. Or statement, one or the other or both have to be true. All right. I've got a great worksheet tomorrow. You're going to love it. Okay. So now let's do this. I think all of these are important especially for tomorrow. So I want to make sure everybody's happy with 28 through 37. Write each in the if then. So let's do 41, 43, 45. Man. And I just want everybody to do 46 through 57. That's the counterexample stuff. If a banana is blue, automatically we can say that's what? Say it. True, right? It's so silly. But I need you to do the practice. All right. So here we go. Here's your job. All right. 28 through 39, 41, 43, 45, and 46 through 57. Come on. Please. 28 through 39. Those are easy. Whatever this assignment, whatever page this is. It is pages 125 through 126. Does anybody else need me to repeat that?
Hey, you don't remember, you don't have to do it.
Yeah, see what happens tomorrow when I see your paper. All right.